Welcome, everyone. So first off, thanks for coming. I hope it's going to be a great conference. I think there's already been some pretty cool announcement and stuff, so hopefully we can keep up the pace. With that, let's jump right in. We have a ton to talk about today, and I don't want to waste too much time. So what I want to start out with today is what Nessie is and what motivated it. So some people may have already come across Nessie in some other talks or seen stuff online. I just want to level set, make sure everyone's really clear on what Nessie is. And then we're going to get into a little bit more depth about what transactions are in Nessie and the two types of transactions in Nessie and how they can be used. We'll finish off with some examples of using Nessie from Airflow, and this is to use what we're calling atomic pipeline transactions. We can see how those will work using it in a real Airflow use case. And then finally, we'll talk about the recent past and the future of Nessie, along with plans to GA Nessie. So let's dive right in. So when we started thinking about Nessie, we were thinking about a lot of the problems, not necessarily problems, but a lot of things that were difficult in data lakes. So things that were hard for people to use, or hard for things to work smoothly, or just general challenges in the data lake world. And we had experienced these problems ourselves. We talked to a lot of people about these problems, and we found that there's basically two clusters of problems. And then looking closer at those two clusters, they were actually the same problem, just using different languages. So when you look at it, there was a set of problems that had the database administrator language, and a set of problems that was coming more from software engineers. So I'm going to keep on saying the same thing today from the DBA perspective and from the software engineer perspective. And that's to really highlight how this is trying to solve several problems at once for several people. So when we looked at the problems that DBAs were having with data lakes, it really came down to ACID transactions. So you can do ACID transactions on single tables. There's some support for Hive transactions. Obviously, there's Iceberg at Delta Lake and stuff, but it's really hard to do large-scale database-wide transactions. And then when you're looking at it from the software engineer has all this fun stuff with DevOps that they want to apply to data, do data ops. And then there's a CI/CD pipelines, and how can we start treating data like we treat all of our other assets in software engineering, and as well closely related is reproducibility, and that comes down to machine learning models and decision reproducibility and stuff. So when we started looking at these two problems, we really saw that they're actually kind of the same problem. So first off, from the database perspective, we started out in sort of an untamed wild world when Hadoop first came around 15 years ago. We really didn't know how to do anything that databases have been doing for 40 years. So over the course of the past 15 years, we've added tables through technologies like Hive, and then we started adding more sophisticated SQL interfaces via Dremio and Trino and these sorts of things. And then most recently, we've added table formats. These table formats are things like Iceberg and Delta Lake. And these are really important abstractions that both provide us transactions and raise the level that data engineers are thinking about problems on the data lake. So for example, previously, when doing things on the data lake, we had to think about where does this Parquet file live? How big is it? Does it have the same schema as other Parquet files? Is it in the right directory so it'll get picked up by partitioning, all this kind of stuff. And now when we're talking about table formats, we're actually starting to think at a level above that. So now we can think of when we're adding data to the data lake, we can do an insert into an Iceberg table. And then we're writing data to a table, and that means it's a lot more intuitive about what's going on, and Iceberg can start taking care of things like optimal file sizes, making sure it has the same file schemas, lives in the right partitions, all that kind of stuff. It really sort of raises the level in which we can think about problems.
Hey, Ryan, real quick, I think your slides are not being shared. Can you, I think in the upper right-hand corner, you may have like a share button or something.
I see the YouTube video still. I can see me screen sharing though. Let me try again. Can you see that?
Yeah, let me see if I don't know why it's not showing up there. I don't know if Dean can help. I'm.
Yeah, Dean, I think the YouTube video is still being shown.
Yeah, I don't. Okay, let me go check with him. I don't know why it's not doing that.
I'm with you right now. Ryan, you'll have to hit share audio and video.
Yep.
And then within there, you'll see a space to where you can share your desktop.
He had tested it earlier, so I'm surprised
Yeah.
it's not working now.
So everything is shared.
Okay.
And I can see the screen share of my desktop.
Right. Wondering why this video is taking over. Let's see if I can.
There you go.
There. Yep.
Gotcha. Okay. Sorry about that.
Thank you.
Okay, sorry about that. So far you guys haven't missed much in terms of slides. So if everything's okay, I think I'll just continue from here. We were discussing how we can sort of leverage the idea of table formats to really make the thinking about data in data lakes a little bit simpler through abstractions. So when you look at what's still lacking then in the data lake, we can do transactions on single tables using Iceberg, but we can't do multi-table transactions. And that's really what our database administrator is looking for. So that gave us the idea of trying to go up another level of abstraction. So now that we have this really clear idea of what a table is in the data lake, let's try and create a collection of tables. So now we're thinking about a metastore or a catalog or something like that. So that was the main insight we got from database administrators. They're looking for effectively a metastore or a database in the same sense that they have a database on traditional databases. So now what can we learn from software engineering? So as I said, some of the problems we were seeing all kind of relate back to being able to version control stuff. So when we look at the rise of these technologies like analytics engineering, what this really comes down to is treating our analytics, our transforms and these sorts of things, treating those as versionable objects and being able to deploy those and do testing on them and stuff like that. So again, some sort of version control. And when we look at data quality observability, we can start to think of data quality as unit testing and integration testing our data. And that's most easily done in sort of a CI/CD environment, which again involves Git, or at least version control. And again, data ops is bringing all the lessons from DevOps into data. And one of the key components of DevOps, as we know, is Git. So all these things require Git, reproducibility, and being able to save a snapshot of your data. You can think of that as a tag. So again, version control. And then finally, atomic pipeline transactions. And the idea behind this is being able to extend a transaction past the database and be able to do much broader transactions. And as we'll see, this also invokes some sort of version control. So when we're looking at the problems faced by software engineers and faced by database administrators, we see that database administrators want a catalog and software engineers want some sort of Git capabilities. So can we create a catalog that gives Git capabilities? And that's effectively what Project Nessie is. So you can think of it as a catalog or a metastore with Git-like experience for the data lake. I say Git-like for a very, very clear reason, which we'll get to in a few minutes. But what it means is we can bring concepts like branches and tags, commits and merges to the data lake. This metastore is also built to be cloud native, so it's easy to scale out. It has very high performance and can be deployed in a variety of ways on the cloud. And the idea here is to really take advantage of the new technologies and innovations happening in the cloud space and really make this, set this up to succeed in the future. And of course, this isn't going to be very useful if it doesn't support a lot of common data tools. So currently it supports Iceberg tables, Delta-like tables, and SQL views. We're not really dealing with tables that don't have a table format on them because we really want to encourage people to think about their data like a database, like a set of tables being managed by a catalog rather than trying to manage things at the file level. And aside from being able to support the table formats and views and materialized views and stuff, we want to integrate with all major data tools. So that's things like Spark, Germio, Trino, automation tools like Airflow, data lineage, data catalogs, everything. The more things that Nessie is able to talk to, the more capabilities we can start imagining in the same sort of organic way that DevOps grew all sorts of interesting applications. We think the same thing can happen using Nessie as the base. And of course, this Nessie catalog or Nessie metastore brings along with it multi-table transactions of two varieties. So I wanted to go back and discuss what we mean when we keep on saying Git-like. And I think this is best captured in the obligatory XKCD comic. We don't really want to be Git. And the reason is captured here. Git can be exceptionally complicated and exceptionally hard to understand for a lot of use cases. And what we want to do is bring some of the spirit and some of the capabilities of Git to the data lake without overwhelming people with having to cherry pick something out of the ref log into a headless branch or something like that. So let's try and take what Git did right and apply it to the data lake without bringing in a distributed graph theory model. So with that, we can define a few core things, terms inside of Project Nessie. And the first one is a commit. And a commit we can think of as completely analogous to a transaction in a database. So this is something that changes, updates, modifies one or more tables or views. So it can be appending to an Iceberg table, updating a view. It can be changing several tables at once, whatever, something like that. The next thing we want to take from Git is the idea of a branch. And a branch is effectively an ordered list of commits. Unlike Git, this list of commits is always linear. We don't have any forks or merge commits or any branches in our history. And these things are basically just human readable names that are connected to a particular hash in the history of a Nessie database. Now, one thing important to mention here is by default, everything happens on the main branch. And the idea here is that Nessie should be, you should only need to use the parts of Nessie that you actually need. So for example, if you're an analyst, you don't really care that your database is a Nessie-enabled database. You don't want to have to think about branches and commits and stuff. You just want to use the database like a database. So that's why by default, everything happens on the main branch. So an analyst, an end user, a consumer, someone from Tableau doesn't really need to think about all the complexity that Git might bring along. Similarly, if you don't need branches, if you don't need these atomic pipeline transactions, you don't need to use branches, and everything can happen on the main branch. And a commit on the main branch is still a transaction in a traditional database sense. So with that, a tag is basically just an immutable branch where you can add commits to a branch, you can't to a tag. And this is really useful for reproducibility. So we can pin the state of the world at a particular time when an ML model was trained or when our end of year data was analyzed, something like that. And the last thing I wanted to take out of Git was the idea of a merge. So this isn't a Git merge with, as I said, there's no merge commits and there's no forking or anything. This is effectively taking everything from a branch and putting it onto another branch. So we're able to make any changes on an ETL branch visible to consumers on main. And that's done atomically as if it was in a single transaction. So that introduces a couple of the potential transaction types that exist in Nessie. So the first one is what we call a single system transaction. And you can think of this as a pure vanilla database transaction. And we can even use the same semantics for it. So this can involve things like isolation levels, and you can do a lot of different, all the kind of the same things you would do in a single system transaction on a normal database, including committing and rolling back and stuff. I think the more interesting transaction that I wanted to talk about today is what we're calling atomic pipeline transactions or multi-system transactions. And the idea here is that we use the facilities of branches to create what looks to the user on the main branch looks like a single transaction. So here we create a branch, we call it ETL, and then we're able to have many different applications, several Spark jobs. They don't even have to be in the same data center. They can be whatever, all contributing to this transaction. In this case, in this example, we have 2 Spark jobs and 2 Dremio jobs happening on this branch. And these can happen in parallel or not, and they don't need to share any context about what's happening on this. All it is performing transactions on a branch. And then once all these transactions are done, we can do a merge. So it has the same semantics as a database transaction, but it has a much different effect, and that many people can contribute to this transaction. So first, let's take a little bit of a deeper look into traditional transactions. So here we can see this has a very familiar semantics, and it works just like we would expect a database transaction to work. And we're able to introduce the concept of isolation levels. Currently, we're working on read committed, repeated, read, and serializable. And what this means is we can really treat the data like a database at this point. We can do commits, and we can do transactions, we can commit them and roll them back. And what that'll look like is a single commit in Nessie. It's just that there'll be multiple tables or views involved in the same commit. Currently, this stuff is being worked on, so there's a pull request in Iceberg to be able to support this, and we're actively working on it in Dremio, but I expect to start seeing this stuff very, very soon in productionized systems. The other type of transaction is the pipeline transaction, and this is ready to be used today, and it's in fact being used today. And the idea behind this is to act just like a feature branch would act in software engineering. So we create a branch, we perform commits on those branches, and then we can do code review, and we can do integration testing and stuff. And once everyone's happy, we can merge it back. So that's what's happening here. In step 1 here, we have a commit on the main branch, and then the data engineer comes along and creates a branch, excuse me. And then on that branch, they perform a series of commits. While the data engineers are working on the ETL branch, anyone who's querying the main branch will see commit 1. And they don't know that all this stuff is happening behind the scenes. So then at the end of the commits in step 2, the data engineers can take a look at the data manually. They can review it to make sure everything worked. They can perform data quality analysis stuff on it that can be automated or not. And then at the end of that, we can say, fine, it's ready to go, and it's merged into main. So then on main, you'll see all of these commits, but they've all appeared atomically. So that the next time a user comes along and starts querying from the main branch, they'll see all these, all the new data that's been added, and they'll see it as if it appeared in a single atomic transaction. So it's not a transaction in the traditional sense, but to the user on main, it behaves very much like a transaction. And it's really, really powerful because these commits, like I said, they don't need to be done inside the same context. Anyone can contribute to what's happening on the ETL branch, as long as it's treated like a branch would be in software, where it's code reviewed and data quality and all that kind of stuff. So with that, we wanted to demonstrate the power of these atomic pipeline transactions. So we went ahead and we built a provider for Airflow. For those of you who aren't familiar with Airflow, it's sort of an orchestration tool used by data engineers, and it's very, very useful when doing large and complex ETL pipelines. So the idea behind Airflow is you define a DAG in Airflow, a directed acyclic graph, and this graph's nodes are going to be operators, and each operator is going to perform some function on the data, whether that's a transform or an add or a delete or whatever. So what we did was we built this Nessie provider provides operators and a connection for Nessie, and it allows us to turn an Airflow DAG into an atomic pipeline transaction, so that a run of a DAG is going to look like a single transaction in Nessie. And this allows us to really start thinking about doing continuous integration on data. So to give us a bit more concrete example, here is the Airflow UI showing a particular DAG, and this DAG is an example DAG from the repository in the previous slide. And in this DAG, we'll walk through it. First, we create the ETL branch, and this is going to tell Nessie to create a branch. And then we're going to perform a series of transactions on this branch, and these can be done from Spark jobs. They can be done directly from the Python DAG, remote, whatever. Doesn't really matter where these are happening. The important thing is they're all happening on the ETL branch that we created in step 1. So all of these things are going to happen. And then once the materialization is finished building, we're going to run a data quality check. And this data quality check this could be as simple as count the number of rows that were added. Or it could be an AI model that's investigating the statistical properties of the data that was added. Or it could be a whole series of checks that's checking all manner of things. And at the end of the day, if these checks pass, we can go ahead and merge into main and delete the branch. So in that way, this looks very much like a continuous deployment, continuous integration pipeline, where the key element here is being able to do these data quality checks as if they were unit tests or integration tests. And then the passing or failing of that determines whether or not we merge the branch. And then just to illustrate how this looked, I've used the Spark SQL extensions to show the log of this particular pipeline run. So you can see the commit message for each of these operations, and you can even see how they're not necessarily in order depending on when Airflow scheduled them. And as well as that, we can get a pile of metadata about the Airflow action. So we can see the run ID and the task ID for each one of these commits, which means that if something goes wrong, we know the hash of each particular task ID, and we can actually go back and revert those commits and then rerun parts of the pipeline. So integrating this commit information into the Airflow pipeline is really, really powerful to be able to find problems with your Airflow. If there's problems with the Airflow pipeline, you can find them. You can then revert and rerun very simply from inside of the Nessie context. As well as this information is exceptionally useful when coupled with data lineage and data quality checks. You can there's all kinds of possibilities to start imagining how Nessie and data lineage and data quality might work together. So this is sort of a beta release of this pipeline. We'd love to get some feedback on how it's working for you and what features we can add to it to make it more useful. At the very least, we want to make sure this is better integrated into Airflow's retry mechanism, and we want to do this with a lot of other orchestration tools. And finally, it's really exciting to start thinking about as I said, all the things we can do with lineage and data quality. So that's something we want to do next as well. And with that, I want to talk about the GA of Nessie. So we want to GA Nessie in autumn. This would mean we have API and storage compatibility guarantees, first-class support for our table formats, more database backends, and our authentication or authorization flow. This means that this can be used in production as of September. And then future work, we have a lot of stuff going on with a lot of tools to integrate and a lot of people to work with to really see what kind of interesting applications we can build with Nessie. And with that, thank you very much for listening. Here's some links if you want to contact me on Twitter or email, and check out our project. We're looking for both partners to work with the software and developers to help us build. Thanks very much.
Great. Thanks, Ryan. Okay, let's go ahead and open it up for Q&A. Folks, if you have any questions, use the button in the upper right side to share your audio and video. You'll automatically be put into a queue, and if for some reason you have trouble with that, you can ask your question in the chat, and I'll try to get it there. Let's take a look and see what we got here. Let's see here. All right, well, I see good stuff, good stuff, good stuff. And let's see if I can actually see any of the questions in the queue. I don't see that actually. Apologize if you guys are asking questions in there. I don't see that for some reason. Okay.
It's either a really good sign or a really bad sign. There's no questions.
Yeah. One says one question is there. I'm just looking for, okay, well, here, I'll just look in the Q&A section. Okay. It says, will Nessie be available in the community version?
The community version of Dremio? I'm not actually sure. I think I'd have to check with product. If you ping me the question in Slack, I'll get someone to answer that for you.
And it says, here's another question from Ben. Can you talk about merge conflicts and how they are resolved?
Of course, that's always my favorite question. So merge conflicts right now are at the table level. So if you try and change a table in two different branches, you're going to get a conflict. Currently, Nessie behaves very much like Git in that it just says you have a conflict, sort it out. Which means in this case, you're going to have to go down to the underlying table library and sort it out. So if you've appended data in two branches to an Iceberg table, the fix is relatively easy and you can use Iceberg to resolve that conflict. If you've added, if you've changed the schema in two different branches or the partitioning scheme in two different branches, then you're going to have a little bit more problem working that out with or without the Airflow, with or without Iceberg tools. So it's something that, similar to Git, it's really the responsibility of the underlying tools to try and sort out those conflicts. But I think it's our responsibility as Nessie developers to provide the tools and the documentation for that. And I think that's something that will be part of GA or soon after.
Okay, now these questions are coming in fast, and we only have 3 minutes, so let's see if we can get them all. How would you compare Nessie to like FS and other differences?
I think the main difference between Nessie and LakeFS is the at the level we've put our abstractions. So LakeFS is looking at things at a very granular file level, and we're looking at things from the high level, sort of this catalog level. So we're kind of at opposite ends of the spectrum in terms of abstractions, but we do a lot of the same things. And I think what it really comes down to is your specific applications. I think LakeFS will be easier for some use cases and Nessie for others. Obviously, I prefer the catalog level abstraction, but it comes down to personal taste, I think.
I think this is a related question. What is the granularity of versioning on the data sets controlled and versioned by Nessie?
So it's really at the Iceberg manifest level, if that or metadata level, I suppose, or the Delta commit level. So if you append a pile of data to an Iceberg table, all you're really going to version is the fact that Iceberg table A moved from snapshot B to snapshot C. You won't know necessarily which files were added or which were deleted or which rows changed or anything like that. You can of course you can back that out from the Iceberg metadata, but in reality, Nessie's only tracking the fact that Iceberg has a new snapshot.
Okay, rapid fire. Is it on the roadmap to integrate with DBT?
DBT, I'm really interested in integrating with DBT, and I would love to have someone from DBT reach out for me if they have any ideas and want to collaborate. I think there's a lot of opportunities there.
Yeah, I think we'll figure that out. Let's see. Is Nessie implement Spark Catalog API? Is it Hive Metastore compatible?
It's not Hive Metastore compatible. I'd love to see if anyone has any opinions on that. It's been a really tricky one for us. Ping me on the Slack channel. And for the Spark catalog, it basically uses Iceberg's or Delta's libraries, and both of those implement a catalog. So yes.
Okay, I don't know how much time left. We have seconds. Can you diff two branches?
Yes.
Okay. All right. That's all our questions. Okay, so folks, that's all the time we have questions for. If we didn't get your question, you'll have an opportunity to ask Ryan in his Slack channel. So if you go to the Subsurface Slack workspace, but before you leave, we'd appreciate it if you would fill out the super short Slido session survey in the upper right-hand side before you leave. And the next sections are coming up in just 5 minutes. In the meantime, you can go check out the Expo Hall. Thanks to everyone, and really hope you enjoy the rest of your show. And nice job, Ryan. Thank you.
Thanks. Thanks a lot for coming, everyone.
Okay, I think that's it. All right, Ryan, I think we're gone. We're done. We had at one point over 200 people live.
Oh, that's cool.
Yeah.
Do you know how that compares to the other?
Well, you're the first round, so I didn't look at the other sessions, so I don't know. But 200 is a good number, you know. I don't know how it compares, but it feels good.
I'm happy with that. I'm always going to think I can do better, but I'm certainly happy with 200.
Yeah. Oh, Lawrence says we can still hear you.
Oh.
Okay. So
All right then.
I know they'll cut this part off for the video, but hi everyone. So,
Thanks,
all right.
Andre. All right, I'm going to stop embarrassing myself and get off this before I say something I'll regret.
Yeah, me too. All right.
Thanks
Cool.
a lot for the intro, Dave.
All right, have a good night.